anywhere, or after that only you directly started for preparations?
Sir, actually, I have taken the apprenticeship in
Is he audible?
Prepared self.
Sir, I have taken GATE from home institute.
Oh,
It's
good.
Hyderabad.
Good, good. Okay. So Harish, so this is my first question basically for you. So can you please draw and show me the single phase cycloconverter is circuit basically?
Sir, single phase cycloconverter.
Yes, yes. Roughly you draw, not specific means just rough circuit.
Sorry, sir. I'm unable to recollect that.
Okay, at least I think you are drawn something. So that
Matrix.
can you show to me whatever you have drawn?
Sir, I can say the use of the cycloconverter.
Oh, no. So at least you try. Means whether it's wrong, that's not the case. But at least you try.
I'm basically confusing in inverter and cycloconverter diagram, sir.
Okay, then do one thing. You draw buck converter.
Okay, sir. So,
You can explain me by means verbally. You can explain. So from the you start from the source.
from source, a thyristor like or chopper, and thereafter there is a one inductor in parallel with the load.
Inductor is in parallel with load, right?
Before the parallel with the load, the
Then
basically buck converter will in first phase from it will supply a source to the inductor, and in
no.
second
So
stage the inductor the stored energy which is
so where is the diode and capacitor in that circuit? Means where you connected?
diode is after the inductor in parallel with before basically inductor is parallel to the source side. After that there will be a diode, and after that there is a load.
And
When
what about the capacitor?
yes, capacitor is in yes.
Okay, anyway, so you please revise this. Okay, so after this interview, this
Okay,
circuits
sir.
and okay. So my next question is have you like heard about the power factor? So what should be its value? So we require it less or high?
Power factor should be high as possible. Basically the power factor is between 0 and 1. The
So if it's low, then what are the disadvantages?
disadvantage, the motor, if we example for we use motor, with a low power factor, the rating will go to high. If we design with a high power factor, the rating and the construction and all the parameters will come to economical.
And what's about the losses?
Losses, when the power factor is high, the losses are minimum.
So there is any fixed value by how much proportion it's low or high, whatever.
When load increases, the power factor will gradually decrease.
Okay.
Based on the coming to inductor capacitor, there is a lagging leading concept.
And what's the size of the conductor? So if we have the low power factor, then we require the higher size or the larger conductor, or the same, or like less size.
Conductor size, when we use the with high power factor, the conductor size reduces.
Okay, so if the power factor is low, then we require the larger conductor size, right?
Larger conductor.
Okay, and what are the different process or way to improve this power factor?
Synchronous condenser. I mean, synchronous generator running in a no load with overexcited, or the shunt capacitor. With this, we can improve the power factor.
Okay. So in India, so mainly when we see about the voltage levels, so we say 11 kV, 22 kV, 33 kV. Why that it in terms of 11 only, multiple of 11 only? So what is the reason?
So basically, the EMF equation dealing with the RMS factor 4.44, so that 1133.
Yes, right. Okay. So when we travel from any trains or metro or whatever it may be, so that basically train is now almost they are electrified by like all trains are now electricity based only. They are not now on the coal based. So this train is powered by electricity. Then why we not get shocked when we are in the train only?
Actually, the rail actors.
Okay, and again, some more like answers.
It is there is no return path to the conductor. Only it will give to the motor or the supply.
Okay. So have you observed somewhere that is where the insulation basically provided? So means the electricity for the to run the motor is coming from that wires. So there is should be some insulator so that all other part of the train should insulate, right?
Yes, bushings.
Okay. So please read more about that. Okay.
Yes.
Okay. So just give me 1 minute. Okay. So in case of the power electronics, what is basically the firing angle?
The firing angle is the thyristor triggering angle. From which angle should the thyristor should conduct in a forward bias.
So what is the other name of firing angle? So there is also like
Triggering
other name.
angle. Triggering angle.
Triggering. Okay. Again, there is also one term.
Triggering.
So delay angle, is it correct or?
Cut-in voltage.
Delay angle.
Is basically. Sir.
Delay angle.
Delay. Yes, sir. Delay angle.
Yes. Okay. So can you just give me a brief advantage of active filters over the passive filters?
Sorry, sir. No concept about it.
Okay. So in case of the electronic system design, basically, what is the purpose of the data modem? Have you heard about the modem system?
No, sir.
Okay, 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 okay. So in case of the electrical measurement, so what is mean by the resolution?
Resolution.
Anything you can say, not in specifically related to measurement, but what is basically mean by resolution?
Resolution means certain range. Range or the
Okay,
span of the.
if you suppose we are measuring register value is resistance by using any multimeter or what, so if it have the high resolution, so what it means basically?
It will be less sensitive to the parameter. High
Mm,
resolution.
no. Again, so can you guess something else? Okay, so basically what happened now? So if suppose I am measuring the suppose 10 ohm resistor value, then if suppose my instrument multimeter or whatever it may be having the high resolution, then it can measure the slight change also, maybe 10.001 or 10.002, whatever it may be. So high resolution, then better the measurement basically. Better we can measure the whatever the quantity that we are measuring. Okay.
Okay. Okay.
Okay, okay. And what is mean by the regenerative braking?
Regenerative braking.
Mm-hmm.
Dynamic braking region. The supply back EMF is greater than the supply voltage. Then the
So where this regenerative
then
braking principle where we can use?
so regenerative braking. It is used in the DC series motor.
Mm-hmm.
No, no, no. While the hilly, while train coming from hilly top to bottom side, like for the generators, the load supply is greater than the supply side. Then from supply is transferred to from load to source.
Okay, 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 okay. Okay. So so we are getting some data. So then we are saying that that data is we are getting from satellite, right? That we say, right? Mostly. So we want to cover the whole Earth to get the data from the each and every point of the Earth. Then basically, how many satellites that are required to the Earth?
How many satellite?
Mhm.
Sorry, sir.
Okay, so basically around three satellites are required, so that are placed at a 120-degree angle. So then it can cover the whole Earth. Okay,
Okay,
okay, okay, okay. Okay, then the next question is, so in case of the hydroelectric power plant, how this electricity is basically generated from water?
so there is a reservoir. The dam is
Mm-hmm.
built across the reservoir,
Mm-hmm.
and on the downside there is a turbine where the water will leave. Mm, So when basically falls from the higher level to lower level, the turbine will rotate, and the turbine is coupled to a generator. So from
Mm-hmm.
generator we can generate the electricity.
So you heard know about the energy can transform from one to other, right?
Yes, sir. Potentially
Okay,
energy
so
is converted to
so the turbine rotate means is basically mechanical energy. So
mechanical energy.
the output is mechanical. Then what is the input energy that they are using?
Potential energy.
Potential
Kinetic,
means stable, right?
kinetic energy is converted to mechanical energy.
Okay. So that water in the reservoir, it also have the kinetic energy or potential energy.
Mm, Kinetic energy.
Oh, it is not in motion. Then how can it's kinetic energy? In the reservoir, I'm asking. Okay, so basically
Water
in
is
the reservoir,
falling.
yeah. So in the reservoir, basically it's potential energy. Then when it's falling, then it's kinetic. Then finally it's converted to mechanical.
From mechanical, it will again converted to electrical by the generator.
Yes.
Which,
Okay. So, can you explain the thin film resistor and wire wound resistors? Basically, their difference.
sir?
Difference between the thin film resistors and wire wound resistors.
Sir.
Okay.
Actually, I prepared for machines and power systems.
Okay. No issue.
This is the first module before there is no selection.
Okay. So, in case of the distribution system, at the end, which type of the transformer basically we have used?
Step down.
Is it star, delta star,
Delta
what?
to star, sir. From star, there, we have available neutral connection so that we can supply three phase and single phase to the consumers.
Mhm. Okay. So, have you like heard about UPS? You know UPS?
Uh, Uninterrupted power supply.
Okay. Then how it is differ from inverter?
So, inverter is just it will store the DC, and when we need it will supply AC. But there is a manual operating. But UPS is directly connected to the our main board, so that when
Mhm.
the actual supply is getting interrupted, this UPS will without interruption it will supply from the inverters.
If you suppose you want to use it for long term, then which one you means which is basically preferred, UPS or inverter for long term operation?
For long-term operation, sir, inverter will available in higher ratings like UPS is for small like computers or small equipments.
Mhm. Okay. So there is my last question. So you saw that birds are sitting on the wires, right? Transmission lines. So why they didn't get any shock?
Actually, to get shock, there must be a potential difference. So
Mhm.
the bud which is on the wire, it's not
Mhm.
grounding, or there is no potential difference for that.
Okay, if suppose I hang on some wires, which is basically current in the current, and I suppose go from one end to other end. So should I get any current or not?
Why? Only one wire will not get shock, sir. But going to higher voltage, it will affect us. But low voltage, it will not.
Mhm. How it depend on the distance of the wire and the ground?
Sir,
How it different from if suppose that wire is at lower distance from the ground surface, and the second case this is at higher distance. So in which case the possibility of shock is more?
low voltage is placed uh, low clearance from the ground. Higher
Mhm.
voltage are placed on towers.
Okay. Okay.
Clearance will be more.
No, if suppose the ground clearance is less, then the chances of shock is more, or
Shock is more, sir. When ground clearance is less, shock is more. We should maintain the limits like
Mhm.
5.4 and for certain voltages.
Okay, Jayesh. So that's it.
Okay, fine. Okay, so it was very nice interview I was seeing. Harish is also like, I think so, he needs to brush up the knowledge. Pawan sir, please provide him
Yes.
Yes.
feedback because feedback is very important so that he can improvise.
Yes. Yeah. So technical knowledge means at least you heard something about what I have asked, right? So, but the actual or the more correct answer you are not able to tell. So maybe in depth or the basic you have to brush up basically. So if suppose I am asking any question, then you are able to tell maybe one or two advantage or disadvantage, but there are more than maybe suppose five or six such advantages. So that also you have to tell.
Basically,
Okay, and that
I
circuit parts also that I've initially told you to draw one circuit. So that's the electronic circuit part also you have to like study more.
This is the first interview. I am not able to recollect those in a tense mode.
That's fine.
And when you were giving the answers, you were not appropriate. Like there was conceptual knowledge to you that was missing, that I can see, but you were not able to deliver also the answers. Right? That delivery is important in when you are targeting HPCL interviews. That delivery was not there. Okay,
Yes, and whatever you are
it was missing.
yes, so whatever you are telling now, so if suppose like if suppose I or maybe that actual interviewer, they might confuse that whatever you are telling, is it right or wrong? So you should have that confidence that no, I am saying so, that's correct, fine. So after they confuse and you might change your answer, so there is, it create a bad impact. So that's
Yes. Fine. So we'll conclude your interview.